Hello everyone, we're live and you are here with me watching Testcontainers Live. My name is Alex Live and I'm your host here for this video podcast where we talk about integration testing, containers, challenges of proper software releasing, how to be confident where you deploy your software, what are the better engineering practices for building applications, and all of that together with various guests. Today is the first episode, so we're just starting this initiative, but I'm very hopeful that we will be going forward in a nice and productive manner. So with all that said, I would like you to welcome in our virtual studio the first guest of this episode, who is Sergei from Atomic Jar. He's the CEO of Atomic Jar. He's one of the founders of the company. And I think today we're going to look at one of the products by Atomic Jar, which is the Testcontainers Cloud. And I think Sergei is one of the better people to talk about that and what state it is, how it came to be, all in all. Please welcome Sergei.
Hi, everyone. That's a great introduction. Thank you, Oleg. And a great list of topics. I kind of like to talk about testing and everything. Thanks for having me, I would say.
Oh, it's my pleasure. It's my pleasure. When I thought about the idea of having a regular stream, regular podcast, and talk about people in the industry, you were the first person that I thought of as my initial mysterious guest. So obviously you have been, would you like to say something about yourself and your path from being a typical Java developer, well, a brilliant Java developer many years ago, but from that to where you are now as the founder of the Atomic Jar company?
Sure. Just a couple of words about myself. Been a developer my whole life. I wasn't a Java developer from the beginning. In fact, I started as a game developer. Early days I started as PHP developer, just don't tell anyone. But then I turned into a game developer with Adobe Flash and everything, and spent like 7 years doing that. So yeah, it's hard to say that I'm a Java developer when half of my career, probably a bit more than half my career I spent not doing Java, but eventually turned into a Java developer indeed. And this topic of testing was always something that kind of made me curious, but also like, I don't know, it feels so good when you can do testing when you develop. I don't know why some people prefer not to do testing, because it makes so much sense. And tooling was so bad back then, but then things started getting better, and I guess today we'll be talking about that. But yes, that's my tiny story of turning Java developer from game developer.
That is an interesting bit. I think I maybe remembered that, but I didn't realize that you were a game developer initially, which is how very many people get in the industry, into the computer science industry, as people call it in the world, but we as insiders call it the industry. You touched on the topic of developers maybe not liking to do testing, and I think this is sort of a fair assessment, but also it's not maybe entirely super precise. I feel like as a community, we've gone miles and miles from not having tests as the general best practice to having decent test coverage, running like a number of integration tests, having some sort of the continuous integration pipelines where like there are some checks on our code. But I do feel that people still underestimate or maybe don't leverage integration testing enough, because there are a number of reasons. And I've heard people call integration testing slow. I've heard people call integration testing unnecessary because they can mock the whole universe around their small component, and a number of other reasons. What do you think is the major bottleneck for, just for, say, Java developers in the Java ecosystem not adopting integration testing to the better extent?
I guess for many years it was rather lack of tooling, because like to do integration testing you actually have to start with databases, and I mean obviously we know one solution for that now, but before it was kind of painful thing, and like we developers, we are lazy, right? And we don't want to spend time on something, especially we don't want to spend time figuring out how to do something we don't know how to do. Like what we know is how to write code, not like how to start Postgres database and then how to destroy it and how to make it start fast. That's outside of our area of expertise usually. And I mean, all these DevOps things have helped a lot, but we're still talking about developers wanting to write code. And I think this will never change, really. Like, I don't think developers will ever stop writing code because it's a great balance of, like how to express what you want to achieve. And there are a lot of conversation about this no-code solutions and everything. But eventually, developers, they want to write code. That's what makes them productive, but also happy. And what also should be mentioned is that integration testing per se isn't slow. What's slow is the databases and other technologies that are being used for integration testing. And unlike we come up with some, creative ideas how to optimize it, obviously we would end up, spending a lot of time just waiting for things. And I know that some use this argument that it is slow, but I'm not sure I would always agree that speed of testing is the only parameter we should be using when we consider doing integration testing or not. And while we are making major improvements on the speed of integration testing so that it becomes more and more like unit testing, I also think that there are many other things to consider, like why doing integration testing. And as you say, like some people prefer to use unit tests and mock out things. And been there, done that, and the result is always you discover that, okay, some of the assumptions you made about your mocks aren't correct, and then you're like, okay, apparently our application isn't working in production. So it isn't about like whichever is better. It's rather what you're ready to trade. Like, are you ready to trade your confidence? I'm not. Like, I would rather kind of wait a bit more, but then have a confidence that my application is working versus running everything in sub-second times, but then deploying it 10 times per day. Redeploying it 10 times per day because apparently it's not working in production. I make a fix, it's still not working. I have no idea how to fix it, and I end up on production server debugging something in PHP style where you poke into the application and you hope that you understand what's going on. So yeah, many trade-offs, but for me it's a sweet spot, the integration testing.
Right. I've heard an opinion from Richard, who is another co-founder at Atomic Jar, that you have a lot of faith in the usefulness and value integration testing provides. And yeah, it's clear. It also makes me very happy because what you are saying is one of the major bottlenecks for more people adopting integration testing currently is not tooling, is not that the ecosystem is not there to support that, but more education about what is currently possible and what are the best practices, and also a little bit of a cultural shift, which makes me, as a person working on the developer relations for Testcontainers library, very happy, because that means my job can make an impact. Having said that, can you introduce Testcontainers library in 1 or 2 lines just to move with the topics forward?
Sounds like a great idea, given this is our first episode of Testcontainers Live. But we already touched on the topic of integration testing and why it's not like better, but like the advantages it brings. And we already mentioned that we need to start real databases. And that's the problem that Richard solved 6 years ago when he was actually, he solved it for himself. Like, he had his own itch, and he created a library just so that he can test his application without running around with a CD and installing software on other developers' machines. And that's how it all started. Like, how do we start dependencies for our tests? And there are options. Obviously, test containers isn't the only option, and it wasn't the first even to attack this problem. And one could say that, okay, you could do the same with Vagrant. And yes, that's indeed the case. You could just describe Vagrant file with, like Postgres, MySQL, some other databases. But there is overhead, and there is also a question of where it should be handled. Like, should you start it from, from your tests, or next to your tests? Do you want to control everything from the same place, being the test seat, or perhaps you would want to have it external? And I guess there are two camps. Now that other camp is still alive, where they start things with Docker Compose, but there are some disadvantages, I would say, of that approach because they're disconnected from the test. And I prefer to keep everything in my test so that test is self-contained. I can just clone an application and run it. And thanks to Docker, great abstraction with the API layer, Testcontainers Cloud just talks to Docker and instructs it to start and stop various dependencies, such as databases, brokers, and everything. And that's how it all works. With that simple idea, it turned out to be a very popular library that is currently being used by, I don't know, like tens or hundred thousands of developers. But the whole point is to talk to Docker directly from a test and then describe everything we need to run our test from our test.
That's a wonderful idea. And that's the wonderful integration. And I know from experience that it is really convenient when the tooling meets developers where developers are, right? So if I as a developer can describe my integration task, can describe my external dependencies using code, right, in my IDE. This is what I do for a living, right? I know how to do that. I know how to prepare that. I know how to use content assist to the fullest, right? I can just start creating there something, right? So for example, for test containers, I can start creating start using one of the modules that the library provides, and then my IDE will just show me the way, right? It will autocomplete all the options that they have there. It will autocomplete parameters. I can see how exactly things are being wired together, so I can understand better how to create this. And it's in general, this is, as a developer, this is what I want. I want to be in my IDE as much as possible. I don't want to go to other tools. I do have to write some YAML. This is a necessary trade-off for being a modern and reasonable developer working with the cloud services and whatnot. But in general, I would prefer to just do everything with code. And test containers give me that opportunity.
And test containers is YAML free as opposed to Docker Compose. So that's already an advantage, right?
Right. That is a very good advantage. Can you share your screen for a second and show on the test containers website, there is a list of modules that test containers has. And I want to ask a cheeky question to you. Which module is your favorite there?
Just a second. The good thing is that I already have an answer to that one because obviously I have my favorite module.
Right. So
okay,
yes,
so
they're on the left. There is a list of modules, which is an extremely long list. There are everything, all the databases, and everything else. Okay, so yeah, peak favorites. We're now.
And the winner is Kafka.
Okay.
Because that's a pain in a well-known piece of the body to run for testing. Not because of Kafka itself, but because it's designed for production and it's optimized for production. But its protocol makes it kind of challenging to use it for testing. Do you know why?
Why?
I mean, maybe you do. I'm just
No,
curious how well known this information is.
I don't. I think I've heard things about that, but I would not be able to articulate that as nicely as someone who actually knows what they're talking about.
Okay, so first of all, if you Google for something like, I don't know, Kafka, testing, Docker, then most probably you end up, I mean, nowadays I think you end up with test containers among the first results on Google, but you may also see something like Docker Compose. And the thing is, and I'm not sure if it's going to work here, but let's try Kafka, testing, Docker. Can you still see it?
Yeah, absolutely.
Okay, awesome. But I'm sure if I just open some of these links, then we'll see something like, oh yeah, that's my favorite. Cool. So, oh, by the way, I think I need to open it into the same. Yeah, okay. Let me just open it into the same screen. Okay. Do you see YAML?
Yes, I
Okay.
know. There are a couple of Bootstrap servers. There is a couple of zookeepers, which the community was very happy to know that they're not necessary anymore. But it's still, yes, it's a production grade software where for the best getting started or operations experience, you need at least like 3 brokers because they're doing things together.
Yeah, I mean, you can also go with a single broker and then you just set topic replication factor to 1 and everything. So it can be as simple as this. And with Kafka 6 and Craft and everything, we could even get rid of Zookeeper. But there is a problem here. A problem that I see, but not everyone would spot immediately. This line. Why there are 2 numbers? Why not just 1992, which is Kafka's port? And the answer is because it has to run on a static port. And in fact, you see it duplicated here. The reason being that when the application connects to Kafka, the way Kafka protocol works is that it will tell the application, hey, reconnect on this host and port, on this advertised host and advertised port. And nowadays, I think it's a single property, but it's always the application reconnecting to the container. And it works well when you're running in production, when you are in the same network, so that when you reconnect, you, like for example, if you connect to this host, what I'm not even sure this is gonna work, I'm just not really sure how it works, but everything will be fine. But if you're running it for testing, if you actually start things, especially if you want to start them on some CI system where you want to avoid port conflicts and everything, you would rather want to run it on random ports, right? Because like, why would we run everything on static ports, especially if we started from tests? And the thing is, if we just start Kafka on random port, so for example, if we remove this 1995 and if we just specify 1992, Kafka's original port, then the application won't work because it will connect to 1992, not 1992, but like something like 31230, some random port. And then Kafka will tell the application, hey, in fact, I'm running on localhost 1992. The application will try to reconnect to 1992 and everything will fail. In fact, I have this funny story when I actually had it once where we spent like, 2 hours debugging the problem. I think it was even before I created this Kafka module because it was one of the triggers for me to start working on it. But Kafka was running on random port, but there was also local Kafka available, running on localhost 1992. And I think what was happening, and it was 4 years ago, so bear with me, I may not remember it correctly, but I think what was happening is that the application was connecting to Kafka. Kafka was like, yeah, I'm running on localhost 1992. The application was reconnecting to localhost 1992, and now it's connected to some other instance, and everything worked fine. More or less, up until my colleague, he wanted to upgrade Kafka. And then we spent 2 hours trying to figure out why Kafka is reporting some old version. I think it was 0.9 to 1.0 update, which was a major update of Kafka. But it was kind of an adventure to figure out that apparently application was reconnecting. This is why Kafka module for test containers is my favorite, because that's exactly what we can do with test containers. We can start things on random ports because we control the lifecycle. And in this case, when we start Kafka, we start on random port, but then we also instruct Kafka that, hey, now you're running on this port. Please report this port to the users. And this is why we also provide this convenient method get bootstrap servers, so that you don't need to figure out how to run Kafka for testing, how to run it on random ports, how to do whatever you need. You just use the module, you just instantiate it, and you ask for bootstrap servers, and you're good to go.
That is an excellent story. I had a feeling that you're going to go with something technical. if you would ask me, my personal favorite are the cloud stack modules, where you can test against your local stack or test against the Google Cloud services. So your cloud deployment would be more reliable when you actually will deploy that. But this is great. What you saw there, and what is the message to take away from this, I think, is that Testcontainers supports like a whole fleet of technologies. And I know that there is more. There is API to programmatically create containers, and it's the whole solution, right? It's the whole solution, but it is a library. So given that it solves like the technical problem of integrating code with the external dependencies, how does Testcontainers Cloud and how does what Atomic Jar builds enhances that experience?
Good question, and I'm happy to answer, because that's where I'm getting excited the most. These possibilities that we bring with Testcontainers Cloud, but I guess it's not a surprise that we already said that Testcontainers Cloud is a Docker-based technology, and this elephant in the room, not because of the size, but because of the importance, Docker. We need to talk a little bit about it. Why Docker in the first place? Because it is an awesome abstraction. For integration testing, there is no technology that is better than Docker, period. Kubernetes isn't any better, because Kubernetes is focused on production deployments. And when you start considering various use cases for testing, when you start thinking about networks, dynamic attachment and detachment from networks, volume mounts and everything, then you realize that, okay, apparently Kubernetes Kubernetes APIs are not enough to perform all the operations we want to run for integration tests. Yes, a subset of them maybe, but we should also remember that Kubernetes isn't something ephemeral, nor it is something lightweight. Yes, there are projects something like KSVS and micro Kubernetes and everything, but there are so many varieties of Kubernetes out there that it's really hard to rely on it as a common abstraction, to be honest, although it was supposed to be one. While Docker remains an amazing abstraction. We don't really care how you start Docker. Literally, as long as you have Docker running or Docker compatible thing running, because there are some alternatives now. For example, Podman, it provides alternatives to Docker by providing Docker compatible API. But let's focus on Docker for now. Docker is an abstraction, but then it needs to be running. And now that we have some either enterprise systems where Docker cannot be provided just because it requires a lot of privileges, or we have some super modern CI/CD pipelines where we run everything in containers already and we cannot start Docker as Docker and Docker solution, or maybe we just want to run it locally and we don't want to run our tests locally and we don't want to have Docker, or we cannot have Docker. For example, I'm on Apple M1 machine, and I would like to use Docker on this machine, I guess, but I simply cannot because there are so many x86 images and Apple M1 is ARM, and yeah, that's a blocker for me. And based on this, we ended up with an idea that why don't we start providing this environment, or not environments, but like this execution environments for test containers based tests. Why don't we take these Docker workloads from users' machines, from CI machines, and move it to the cloud? And it's a very simple idea, or at least it sounds like a simple idea. In fact, someone could say, okay, I can do Testcontainers Cloud in 5 minutes. I could just start EC2 instance and then connect to it through, I don't know, whatever I use. And yes, that would be a very interesting prototype. And that's how we also started prototyping. But then when you go into details, you realize certain things. So for example, Testcontainers Cloud, in fact, is an edge platform. And by edge, I mean we are bringing workloads very close to the users. So that it's not just some data center in California making everyone in California happy, but then Europeans quite unhappy due to the latencies because you're still running your tests on your machine. Nothing changes to how you run your tests. But what changes is that you're no longer running the workloads on your machine, so we need to have them somewhere and ideally somewhere close. And this is one of the aspects of Testcontainers Cloud that makes it so unique, that we aren't just something that runs in the cloud, but we are something that runs close to you, and that makes a lot of difference.
That sounds very cool. Bringing the execution environment for your workloads to the cloud, but to the cloud near you sounds like a great productivity booster. I know that when I run Docker, and not on this M1 Mac, but when I ran Docker before, the fans on the laptop started spinning. It quite quickly became unusable for other tasks. So I think delegating that to the cloud instance makes a lot of sense. Maybe enough words. Maybe you can show Testcontainers Cloud to us in rather briefly. And I know
absolutely happy to.
We haven't talked about that yet, but Testcontainers Cloud is currently in the private beta, which is where it's not available to everyone yet, hopefully. Yeah, so I think taking a look at how it feels can give enough motivation for people to reach out to Atomic Jar a little bit more eagerly. And there is a procedure how you can register for the beta currently, and maybe you would like to do that.
Sure. Let me share some of this information. So first of all, let me terminal a couple of things. So yeah, I hope you can see my screen and you are in this session. Okay, cool. So first of all, what I have on my screen is my favorite type of test. And this test, an empty test. Yes. Like I keep saying that this is my favorite type of test. And I guess since I'm talking about it all the time, perhaps you can tell me why it is the best type of test.
I actually haven't heard you once say that, but this is a fully functional test that actually runs. You can run it, you can see it pass, you can very easily make it fail, which is the precondition for any meaningful test. So yeah, it's a test that is working. It is a fully working test.
Yep. And what's also...
Yeah, go ahead. Sorry.
What's also great about it is that an empty test would always help you debugging what's going on with your test setup, whether it's something with the test setup or with your functionality that you broke. Because, like when we are working on software, we are making changes, and obviously we are using tests, and especially continuous tests, to see, like the feedback, to see whether we broke something or not. And sometimes it may be that we didn't break the functionality, but instead we introduced some regression in our test setup. And we may spend minutes or even hours debugging like why tests are failing, thinking about the application itself, while in fact, maybe we misconfigured the test setup. And an empty test, and I'm so glad that when you go, for example, to start.spring.io, they generate an empty test for you. An empty test is something that would kind of highlight the fact that something, if it's failing, then something is wrong with your test setup, or if it is green, then it's not test setup related, but rather something related to your application. And this is why I always have them.
Excellent.
And if you run this,
can you make it look a little bit larger as well, please?
Yeah, I'm pretty sure I can. Just try the presentation mode.
Oh yes, this is so much better.
Yeah, I haven't been doing conferences for years actually. Jeez. But okay. So as I said, we have a red test here, and what's going on is I don't have Docker on this machine. Like if you look at how, no, I don't have Docker. Like if I try to use terminal like Docker PS, cannot connect to the Docker daemon. So no Docker here.
No Docker, fair and square.
Yeah. But I want to run this test. And in fact, some of you may have noticed that I'm using our own like Testcontainers Cloud, like one of the pieces of Testcontainers Cloud here, because that's indeed what we do. We, of course, dog food our own product, but in our case, it was even more important because when we created it, like we needed to run the test, and I started with Apple M1 and I couldn't run the test, so I had to deploy something so that I can run the test myself. So now if I run Testcontainers Cloud Desktop, which is a tiny application, just a tiny application, as you can see, it's already running. You can consider it an agent that connects you to the cloud environment. But the good thing is that you don't need any privileges to run it. You don't need to have root access to your machine. It's a tiny Golang application, in fact, that won't consume much of your CPU and memory. But now, if we rerun the same test, we should see a different result, unless I messed up something, but hopefully not. And the good thing is that, okay, something is going on. Awesome. And the tests are starting. Since I'm running it for the first time, I'm gonna download the images, of course. But the cool thing is that the images are being downloaded very fast, 18 megabytes per second, because we are running it in high performant clouds. And obviously these clouds, they have a great network connection to Docker Hub and other registries. And sometimes, or not sometimes, like most of the times, the images will be downloaded much faster than on your local machine, which is another great addition. And obviously, we'll be making improvements to that one so that you won't even notice images being downloaded. But now that we have the image downloaded, the test is finally green. And this is the best thing possible, turning red tests into green tests without changing their code. Because that's another way of making tests green. We could just, like, ignore. Okay. So.
Right. So lead me through some of the details here, right? So now the test setup is as follows. We run it still on your machine in your IDE here. And when it looks for a Docker environment, it is a test that uses test containers, right? We didn't change the test. There was no code changes necessary. Yep. So the same way as test containers previously looked for a Docker environment and didn't find one and failed, now it went looking for a Docker environment and it found something that is the Testcontainers Cloud desktop application running. And through what happens next?
As you said, we do have this discovery mechanism in test containers. One thing that makes it awesome, actually, what I like, and I'm referring to many things in test containers as awesome because I wasn't the one who created them. Richard did. This is why I'm just praising his work, and I'm not talking about something that I did. But this mechanism in test containers would do best effort to find Docker, and there are multiple strategies. So it isn't as simple as just relying on, var run docker.sock, because on Windows it won't be that path. Or if you're running with rootless Docker, the path will differ. And there are so many things that may not be the default values. And one of the strategies indeed would look for Testcontainers Cloud environment. And as you said, we did not change anything in our test setup. So it's the same test setup. In fact, if I turn off Testcontainers Cloud and if I turn on Docker, assuming that I can run this on this machine, run the containers on this machine, then I would continue using local Docker. So it's not like vendor lock-in to the cloud. It's just a complementary thing that dramatically improves your experience with test containers. But here, if you look into the log, then we'll see that we were able to find Docker environment with environment variables, system variables, and everything. Then we connected to Docker. As you can see, the server version, usually you would see something like Docker version 20.04 or something like this. But here we see our internal version because we are running our own build of Moby. So we aren't running exactly Docker, but we're running our own build of Moby just so that we can also make our own improvements to that one focused on specifically integration testing. And as you can also see, we got allocated quite a good amount of resources. In fact, on this machine, I only have 16 gigs of RAM, while what we had allocated is 32 gigs of RAM. The exact numbers in GA are TBD, and we are just showing you the private beta and how it feels to use private beta. But what I want to say is that in some scenarios, you may be getting much better CPU and RAM that you would get locally. And if you think about it, if you're running on low-powered devices, or if you're running your CI on ARM, or you want to optimize the cost of your CI, that's a great way to perform the optimization, because as seen previously, this environment was started for us on demand, meaning that if we don't need to run integration tests, we won't be running these beefy machines, meaning that we won't be paying for them, which is another great advantage. And another thing is that, yes, this environment is on demand, but what happens if we rerun the test? What happens if we want to continuously run our testing workflow, ITDD, so that to say, like integration testing, integration test-driven development? Then we won't be, as you can see, we won't be pulling Cassandra image anymore. In fact, Cassandra was available to us in 0.5 seconds, less than a second, because it also supports reusable containers mode and other optimizations that we are making in test containers. But now, instead of waiting for how many seconds we waited last time, I don't know, maybe 30, 40, now our tasks executed much faster because we already have the environment running. And then if we constantly rerun the test, we always have the environment available. If we stop running the test, eventually it will get terminated. So we can think about it as a serverless approach to test containers, where we get resources when we need them and resources aren't allocated when we don't.
Right. That is an interesting way to put it, like a serverless backend for the test containers based integration tests. Very nice. Yeah, I think this is a fairly comprehensive demo. I don't even know if a Cassandra Docker image runs on M1 Mac nicely or not, but here it clearly downloaded, started run. If my setup for the test is a little bit more complicated, right? If I run, for example, two dependencies on the same Docker network, right, exposing the same network, are they being run within the same like compute instance, like compute unit that you're offering, or are they somehow separated and there are any challenges in making that setup work?
I guess the same serverless mindset applies. Why would you care as long as it runs fine? So first of all, to answer the question, would it run? Yes, it will. So every existing function of test containers is currently supported on Testcontainers Cloud. So you aren't getting limited by the cloud version, which is great. So that you can continue using networks, you can continue using some advanced containers such as Kafka container. You can do reusable containers. You can do standard things, something that you were used to when you were running test containers, like the original project. And under the hood, there is some magic that is happening, and while currently it's focused on running in not like environments, but like this Docker thing, eventually we'll also be doing some advanced optimizations in that one, so that it can scale beyond. I don't know. Let's say we have this 32 gigs of RAM. But what if we want to go crazy? Like, what if we really want to go like, really crazy? Like, what if we want to start something big, something we shouldn't be doing, frankly speaking? But if we want to, then Testcontainers Cloud, we also support that eventually.
I mean, yeah, if it's backed by a cloud, there is an unlimited compute resource there, so it just effectively eliminates that bottleneck altogether. Right,
yep.
And
in some way,
I can still, what you said, like the functionality support, I can still like copy files to containers, copy files from containers, access logs, all that what makes test containers kind of sort of a go-to instrument, go-to tool for integration tests.
Of course, of course. Obviously, you have to be mindful of things that were even previously were not supported kind of in all environments. So, for example, file mounting. Since we are talking about a cloud version, like file on your machine won't be the same as on some cloud instance or something like that. And we don't have any mechanism for synchronizing files from your local machine to the cloud because it's also important for the privacy and everything. We don't want to move your code. In fact, what we try to do, we try to only focus on what you need to start for testing, but not like we would be taking your tasks and submitting it to the cloud, executing them, and returning back. That's not what we are doing. But for the file operations, that wouldn't even work if you run Docker in Docker, for example, unless you configure the process and everything. And this is obviously the limitation, but we've been advocating the copy API for years. And the copy API, which is something that would let you to kind of copy file from your machine to the Docker daemon and back, would of course work as well as logs. And some people tend to assume that fixed ports is something that they should be doing. And we've been telling that, okay, there are reasons why fixed ports may not work in various environments, Docker and Docker included. And this, like the same thing applies here. Obviously, by running Testcontainers Cloud, you are no longer exposing ports just on your machine. And your local port isn't the same as port on some remote machine. So if you had these assumptions in your tasks, then some of them may not work. But for every such assumption, we provide alternatives and alternative approaches that we were advertising for years. And this is especially important now that we have Testcontainers Cloud, because Testcontainers Cloud builds on not like best practices, but we want to focus on how to make Testcontainers Cloud the most efficient and kind of the best solution for that, and just make sure that you aren't ignoring some of the recommendations we were making before.
Right. I think that is fair. You can always try to find ways to like break the system, but if you're within the reasonable guidelines and if it doesn't take too much out of you, then if it works, it's all great. Right. Okay. I have two more sort of questions. One, I hope people are very interested in Testcontainers Cloud now. How would they get access to such a magnificent piece of software engineering? I can answer maybe that, actually. I want to share my screen anyhow.
Yeah, I'm actually looking forward to what you have to show, because I'm just a guest here, right?
Yes, that's why I'm asking you all the questions. So yes. To answer a question, you can go to answer my question. Lol, to answer your question. My question. To answer the question of the current stream, how to access Testcontainers Cloud, how to get to that. You go to the atomicjar.com, to the website, and then you can sign up for the early access button here. It leads to a Typeform. Currently, we're in the private beta phase, so we are a little bit mindful of how quickly we give access to large number of people. And we want to, so if you just fill a very quick survey about your name and email, how to access, how we can reach you, then it's fairly a simple process. When your time in the queue will come, we will reach out to you and provide you with the onboarding instructions and access to the Testcontainers Cloud. We have a number of very early access beta users, and they have very positive feedback so far. So I'm very hopeful that we can onboard more and more people in the very near future. So having said that, there is another thing that I want to ask you, and I want to show you, which is the other part of how we run test containers and where we run integration tests, which is the continuous integration pipelines, of course. right? So you showed how a developer would run Testcontainers Cloud client application and then execute their tests from the IDE. The same way it will work from the same workstation running from the command line if you're just building your product, you're building your software. But also, there is something to say about improving the experience of running integration tests from the CI pipelines. And Testcontainers Cloud works for that as well, and it does it in the same manner. There is a very simple, small kind of sort of user space, not requiring a privileges application that you can install into your pipeline using the appropriate mechanism for that, and then you just execute your test normally. So I have a small example here, which is the same application with one single test. And I have an example using GitHub Actions, right, which is one very popular CI/CD pipeline, like continuous integration build tool, right? And one example using the same application, but using the GitLab
nice.
pipeline. So here's my question to you. We can try to run one of those, and we can try to explore one of the setups here. We actually can do both, but they're very similar. So which one would you like to see, GitHub or GitLab?
Definitely GitLab, because as someone who's been replying to many questions about test containers, I could easily say that running test containers on GitLab was among one of the most popular questions, because the way GitLab is running its jobs, it's already containerized. There is no Docker as far as I remember, or sometimes there is Docker, but you need to configure this wormhole pattern. And although we always had this documented on our website that you can find, can you actually open the website just so that others can find it? Because obviously we don't want to kind of blackmail you. We don't want to say that, hey, if you need to run it on GitLab, your only option is Testcontainers Cloud, because that's not what we are doing. We're just providing you an alternative. And you can still run it with your local Docker. You can still run it with your sidecar pod on Kubernetes or what's not. But the setup was rather involved. And as you can see, you need to run it as, let me check. Okay, it's no longer, there is no privileged flag here, but in fact, it needs to run as a privileged thing. Because Docker requires the privileges, even rootless Docker requires the privileges, and some sysadmins may not be happy about it. And I totally get it. So first of all, the config is involved, and you need to know how everything works, but also you may not want to run this privileged workload on your cluster, in your CI/CD cluster. We all remember this solar wind story, where their production system was affected by something that got injected at the CI/CD stage. And in fact, this is something that may happen when you have something privileged running. So I'm really looking forward to see, I haven't seen it before, like how it works on GitLab, because I believe this would make many lives so much easier when you don't need to run Docker on your GitLab pipelines anymore.
Right. All fair arguments. Security is a very big concern. Running privileged things near your code is a security concern, at least in some environments and in some setups. Running third-party code, even within the isolation of a Docker container, running it right near your code can be a security concern. That is all true. That being said, there is nothing against GitLab here in particular, as far as I understand, right? There are a number of solutions, continuous integration solutions that run your workload, you run your tests already in various Docker-based environments. So for them, you need to configure Docker in Docker and other usage patterns, which could be maybe a little bit more complicated and involved. So there is nothing against GitLab. This is just how things are when you run in Docker. Right, so let's see. I have my GitLab thing here, and I sincerely hope that it actually works, but we'll see. I've seen it work. There are some setups and some conditions where this demo works nicely. So it's a very simple test, and this is just the default test that we what we have as the base for the reproducing issues with people's test containers based setups. So it does nothing. It creates a very simple generic container based on Redis, and it just exposes ports and it starts it. The test passes if the setup works. How do we configure that for the pipeline? Very simple. I think we need to edit the GitLab CI YAML file. And here was what we do. This is a Maven-based project. So what we say, we're going to use the Maven-based image. And then this is where the configuration for the Testcontainers Cloud access happens. We download the agent, which is the binary application. We download it from the website. We make it executable. Then immediately we execute here, providing the credentials for accessing the cloud. And we use the wait command to wait for that connection to succeed. After we have this setup, and it doesn't have to necessarily be a part of your job immediately here. If you can start it somehow in a step prior to this, this would work as well. So for example, if you use cloud IDs or anything like that, you can maybe raise this step a little bit higher as a configuration. So all your builds running the same, say, image here. You can raise it into the base image and so on. Right, so this is, and then we run just Maven tests. Very simple, very straightforward. So this is how we do. And now how do I trigger a pipeline? Pipelines, run pipeline. I think so, right?
I think so too. Frankly speaking, I'm not a user of GitLab Actions, GitLab CI, but right. I know that there are so many users of GitLab CI, and it looks cool actually.
Right, so we have in the project, we have the pipeline, we say where we want to run this, we run this, and it will take a moment to configure this. It is running build, and it should show us the logs here. So one thing to note, this is using a Docker executor. So it would not have Docker normally. You would have to configure Docker in Docker the way the instructions on the test containers website would work. You can use a heavier, I think, machine executor, virtual machine executor, or something like this to get an actual machine. But
this reminds me of Circle CI, by the way. And we have this recommendation that, or not a recommendation, but basically the way to run test containers on Circle CI is to use the machine executor, but then it will start heavyweight machines, virtual machines, and then it costs more and it's more involved, and not everyone is happy about it, I guess.
Right. Yeah, but the default choice, at least for GitLab CI, if I just pick the default things, as I did here, I think is the Docker executor. Right, so we ran everything, and for some reason it didn't stream our logs, but it did finish fine.
Yay.
Let's see how it worked. So at the very top, it downloaded the agent, which is a 8 megabyte binary file, and it downloaded that, and then it chmodded that, and then it started that. Waited for it to successfully connect and inform that, and then it started running tests. Right, so we can see that it picked some sort of a server with the latency to the server. This is something that responds in 5 milliseconds. I think the cluster where GitLab run this Docker container is very close to the cluster where we run the Docker image that we needed, right? So it's because everything runs in the cloud now, right? It's naturally the latencies there are of a different kind. So 5 milliseconds between the environments, and then it just started the Maven build, download all things. Of course, you can improve this, and in your best practices for running Maven on CI, you would maybe cache the dependencies and all that. But it did start and connected to the Testcontainers Cloud Docker. And you can see that result, and then it pulled that Redis and showed those logs, which I love very much, with the whale emoji there. And the test obviously succeeds. Right. One thing to note here is that configuration requires you to pass the token for authenticating your CI pipeline to the Testcontainers Cloud backend. You would like to hold that as a secret on your project, so it's not exposed in the logs, and it's just, yeah, it's a secret, right? It's an authentication token, so treat it as a secret. But all the continuous integration pipelines, GitHub Actions, GitLab, Cloud IDs like Codespaces, Gitbot, they all have the possibility to configure some tokens, environment variables like that as secrets, which is what we used here. So job succeeded in 20 seconds. I say not bad.
Indeed. That's actually, I'm so glad to see it. And could you please open the config for GitLab CI?
Right. If you want the YAML file here?
Yeah, like this one. Not like I want YAML file, but okay. So what's really cool here is that it's part of your command. Like it's just part of like what you run. So you don't need a specific support for Testcontainers Cloud in your CI provider. And then as long as you can run some bash script in your CI system, you're good to go. And that's indeed the case here, because it's just a bunch of, like download something, start it on background, and then proceed with your main application, which is great, I think, because it does not require any integrations and it can work with any CI provider or Cloud IDE, as you said.
Oh yeah, the Cloud IDEs as well. I think the simplicity of the configuration there is the thing, and you can see there in the chat people are saying that this is something that they need because the M1 Max are incoming, and Victor Gamov from Kong is a person that says that they would love to have access to Testcontainers Cloud. Just to remind you, if you want access to Testcontainers Cloud, please fill the survey, sign up for the early access, and enter the pipeline, and trust the process that we will be able to give you access as soon as we can possibly do that.
Yes. And to answer the question about the necessity of having TC Cloud token, it is not strictly necessary. Like we support environment variables as a source of configuration. So it can either be a flag or environment variable. There is also a config file should you want to manage it centralized. That's specific to CI providers because, CI systems where you need to run it in a handless mode, because when you're doing it locally, then you don't even need any tokens or anything. You would just install the application to open the web page, and then you will log into the web page, which is a big advantage so that you don't need to do the document management at all unless you want to. But yeah, it's a tiny client utility, kind of. I mean, I cannot even say that it's an application, at least we're talking about the CI providers, that would do all the magic for you and will connect you and your environment to Testcontainers Cloud. And I guess we don't have time, and I think we're running out of time, but I wish one episode would focus on Cloud IDs, because that's where I'm also getting excited about like just the idea of running a small Cloud ID instance with just some RAM, some CPU, but not like 16 gigs of RAM, and then running Testcontainers Cloud only when you need it, when you start your Testcontainers-based tests. I see it as an interesting approach to the development overall, where everything is lightweight and you can continue doing it. Like you can continue running your Testcontainers-based tests no matter where you develop.
Oh, absolutely. I think we should absolutely figure out some Cloud IDs setups and some streams about topics like Cloud ID and integration, how to run integration tests from GitHub Codespaces, how to run integration tests from Gitbot. If you are watching this now, and if you have any ideas, what topics would you like us to cover in the future, what would be a good suggestions, please reach out. The easiest would be to just Google either Sergei, he almost universally goes by B-side up, in social or emails and everywhere, or you can ping me. I'm Oleg. I go by @Shalaev on Twitter, GitHub, or you can email us at Atomic Jar, and then suggest the topics. I'm looking forward to the next episodes we will figure out the schedule and publish the cadence and the upcoming topics. Next, you can subscribe to this YouTube channel, and then you don't have to actually, you will be notified when the stuff is going live, and you can join that. But with that, I think we can have it entering the final session. Do you have any questions in the chat?
I'm just looking at the chat actually, because if you have questions, please feel free to ask, and we are here to kind of talk about it, but not because we want to, we want to talk, but rather we want to tell you what we are doing here and also hear your questions. And what Oleg said, that if you have some ideas for future episodes, feel free to challenge us as well, because today's challenge was how to run Testcontainers Cloud on Apple M1. How to run test containers on Apple M1, how to run test containers on GitLab without Docker. But I believe there are many more edge cases where test containers were previously not possible, but test containers based tests were previously not possible. And let's see where we can go with this. I have some ideas.
Yeah, they a little bit bold throwing the challenge like that to the internet. I'm sure that someone will send you a microwave that doesn't run anything and ask you to challenge you to run Testcontainers Cloud on that. But at least we'll have.
We'll see.
At least we'll have a microwave then.
Yeah, if you can ship it to us, then.
Yeah, we're worldwide. Just to say a couple of words while we are waiting for the last minute for the questions, if you have any. If you are interested in the Atomic Jar as the company, we're a fully remote worldwide organization. Sergei is currently joining us from New York.
Mm-hmm.
I don't know actually more detail than them. I myself, I am located in Tartu, Estonia, which is a small town in the middle of nowhere in Eastern Europe. And there are people everywhere in the world. So in the full remote fashion, there is no one location where you can send a microwave to hit us all, so to speak. Right, I don't think we are getting any more questions. Thank you everyone who joined us, for watching. Thank you everyone for the interest. Thank you, Victor, for being interested in Testcontainers Cloud. Thank you, Branislav, for joining us, asking questions. Thank you, everyone. We'll see you online.
Yeah, and thanks for having me. It was a privilege for me to be the first guest, but I hope I served the role well. And looking forward to the next guest talking about test containers and everything test containers.
Oh yeah. This would be very interesting. Thank you, Sergei, very much for joining and for your insight, and thank you for your time. Anyway, it was Testcontainers Live. See you online. Cheers.
See ya.